Let's do some problem based on the standing waves. First problem is a standing wave is represented by y equal to a sine 100t into cos 0.01x, where y and a are in millimeters, t is in second, and x is in meters. The velocity of the wave is given expression for the standing wave is y equal to a sine 100t into cos 0.01x. We compare this expression with the standard equation of the standing wave, which is a sine omega t into cos kx. Comparing, we will have omega equal to 100 and k equal to 0.01. In terms of unit, we can say, because time is in second, so omega will be in radian per second, and x is in meter, so k will be in per meter, because we know k equal to 2 pi by lambda, and omega is 2 pi by capital T. So wave velocity of the traveling wave, which are resulting into the standing waves after the superimposition of two waves moving in the opposite directions. It is given by omega by k, and it is equal to 100 by 0.01, that is equal to 100 into 100, or we can write 10 raised to the power 4 meter per second. This is the answer. Next question is, a standing wave having the 3 nodes and 2 antinodes is formed between the two atoms having the distance 1.21 angstrom between them. The wavelength of the standing wave is. So as per the question, there are the two atoms A and B, and in between there are 3 nodes and 2 antinodes. We have already discussed that nodes and antinodes take place alternatively, and distances between the node and antinode are same throughout. So nodes are at the atoms and at the midpoint of these two, and between two nodes there exists an antinode. Also, we have discussed that distance between the two successive nodes is lambda by 2. Similarly, distance between the two successive antinodes is also lambda by 2, and distance between successive nodes and antinodes is lambda by 4. So, distance between A and B, it is given 1.21 angstrom, and this distance comprises the number of distances between antinode and nodes. Suppose this is 1, then again antinode and antinode, this is the distance 2, then third and fourth. So there are the 4 times of the distance between a node and antinode, and we know distance between a node and antinode is lambda by 4. So this implies that 1.21 angstrom will be equal to 4 into lambda by 4. This 4 get cancelled, so we can conclude that wavelength of the wave is 1.21 angstrom. This is the answer. Third question is, a traveling wave is represented by y a sine omega t minus kx. A sine omega t minus kx. It's superimposed on the another wave represented by, another wave is y, this is equal to a sine omega t plus kx. From the equation we can conclude that first wave is moving in plus x direction, and second wave is moving in minus x direction, and similar to the first wave. So we can represent this first wave by y1 and second wave by y2. So by superposition principle, we can write that y net wave displacement is y1 plus y2. This is the algebraic sum, and it will be equal to a sine omega t minus kx plus a sine omega t plus kx. A is common, so taken out, remaining is sine omega t minus kx plus sine omega t plus kx. Using the trigonometrical formula for sine c plus d, we will have 2 sine c plus d by 2. This is c, this is d, and c plus d will give omega t plus kx plus omega t minus kx by 2. And cos c minus d, that is omega t plus kx minus omega t minus kx by 2. So simplifying it, we will have 2a sine. Here kx will cancelled, so remaining is omega t. And in second term, we will have cos. In this term, omega t get cancelled, so remaining is kx. So we can write it as 2a cos kx into sine omega t. And this is the equation of the standing wave. Therefore, we can say that first option, which is the standing wave, is true. For nodes, amplitude of the wave will be 0. This implies that amplitude of the standing wave, which is 2a cos cox. So it is 2a cos kx and it should be 0. This implies that cos kx will be 0. Or we can say that kx is equal to n plus 1 by 2 into pi, where n is equal to 0, 1, 2 and so on. Because k is equal to 2 pi by lambda, we substitute this value. So we will have 2 pi by lambda into x, that is equal to n plus half into pi. Pi and pi get cancelled. Therefore, x will be equal to n plus half into lambda by 2, where n equal to 0, 1, 2 and so on. And this is the points where nodes occurs. So we also say that option 2 is also true. Fourth question is, standing waves are produced. First option is on a string clamped at both ends. Second is a string clamped at one end and free at the other. Third is incident wave get reflected from a wall. And fourth is when two identical waves with a phase difference of pi are moving in the same direction. And here more than one correct options are possible. Let's see first option. Standing waves can be produced on a string clamped at the both ends. If a string is clamped at both ends, then both ends act as a fixed end. And when incident wave strike at the fixed end, it get reflected with phase reversal of pi, and the incident reflected wave superimposed, resulting into the standing wave. Therefore, option A is the correct option. Option B is on a string clamp at one end, free at other. So if at one end a string is clamped and at another it is free with a ring, that means it can move up and down. So this end act as a free end and it is the closed end or fixed end. When a ray incident on the free end, then it get reflected without phase change, and these incident and the reflected ray get superimposed and results into the standing wave. So option B is also correct. Third is the when incident wave get reflected from a wall act as a fixed end. So these incident and the reflected wave get superimposed and result into the standing waves. So C is also correct. Option D is when two identical waves with phase difference of pi are moving in same direction. We have already discussed that condition for the standing wave formation is that wave should be identical and move in the opposite direction. Then standing wave is generated. But if waves are identical and moves in same direction, standing wave do not generate, it results into this condition results into the beats, which we will discuss later. So option D is the incorrect option. Hence, answer is option A, B, and C. Next, we will discuss the formation of a standing wave onto the stretched string.